All right, Pythagorean theorem. A squared plus b squared equals c squared. This works for right angles only. Okay? So it's a very simple formula. It doesn't matter. This is always c. The hypotenuse is always c. Okay? It doesn't matter whether you call this a and b, or you can call it b and a. It doesn't matter. The legs are just the legs. Now, all we do, and I always suggest that you write a squared plus b squared equals c squared every time. It helps avoid errors down the road that I'll show you on the next problem. So, our two numbers were 5 and 12, both legs. So 5 squared plus 12 squared equals c squared. 5 squared is 25 plus 12 squared, which is 144. Add those together, and you get 169. C squared. Well, we want c, so c squared, square root of that is just c. And we square this, which happens to be c equals 13. Now here's what we talked about earlier. Technically, it's plus or minus 13, but we're talking about geometry and we can't have a negative side length. So that means the hypotenuse of this triangle is 13. Now, why did I say it's important to write a squared plus b squared equals c squared first? Because here is what happens most of the time that's wrong. 12 squared plus 15 squared equals c squared. That's wrong. Okay? That is not the correct way to do it. Because look, where is 15? 15 is c. But that is what happens more often than not. So if you do this, a squared plus b squared equals c squared at the start, it doesn't take long. It's not a lot of work. And you do this, a squared plus 12 squared equals 15 squared. Okay? So notice, I put one leg in for a, just a. I put in the 12 for b, and I put 15 in for c. And it would not matter if I called it a or b. So that's a squared plus 144 equals 225. That's too many twos. Okay, 15 squared is 225. Now we subtract 144, and we get 81. We square root both sides. And remember, we only need the positive, so boom, a is 9. So this is 9, the other leg is 12, and the hypotenuse is 15. Okay, so here's your thought process. Is a triangle a right triangle? If the answer is no, stop. You don't know how to solve that yet. If it's yes, you have three choices. 45, 45, 90. X, and x root 2. 30, 60, 90, x root 3, and 2x. And if it's dealing only with the sides of the triangle, Pythagorean theorem. I do want you to make a note here. Legs, hypotenuse, legs, hypotenuse. Okay? All right. Just a quick review. 45, 45, 90. Hypotenuse, leg, leg. So that's 6. That's 6 root 2. Bam. Easy peasy. Over here, do we know the measurement of the angles? No, we do not. All we have is the leg measurements. We don't know if it's 45, 45, 90. Well, it looks the same. We cannot assume. Not to mention, it's not the same because the leg measurements are the same. And you can't assume it's the 30, 60, 90 either. So we need to solve for c. So we do a squared plus b squared equals c squared. We plug in 6 here, we plug in 8 here, and we don't know c yet. So 6 squared is 36. 8 squared is 64 equals c squared. So that adds up to 100. And when you square root both sides, you get c is 10. And that makes sense, again, because remember, the hypotenuse is the longest side. You should always ask yourself, if you get a number that's smaller than the two legs, you made a mistake. Okay, what about this? 30, 60, 90. Okay, well, that's our short leg. That's our long leg. That's our hypotenuse. We have the short leg. That's the best. This is simply 7 root 3. This we double 14. Over here, we have no angles, so we have to use the Pythagorean theorem. A squared plus b squared equals c squared. Now again, it doesn't matter what you call it. This is A, let's call this B. So 5 squared plus b squared equals c squared, which is actually 13, so I screwed that up. So 25 plus b squared equals 169. If the board would let me write the numbers. So 169 minus 25 is 144. So b squared equals 144. Square root both sides. B equals 12. So this length right here is 12. Okay? Just reviewing. I don't know how this got moved down, but reviewing again. Okay? 45, 45, 90. These are the same. To go to the smaller side, I'm going to divide, and I'm going to divide by root 2, so that makes it easy. It's just simply 13. Because you have 13, root 2, divided by radical 2, cancels. Here's my short leg. Here's my long leg. Here's my hypotenuse. I always want to try and get the short leg. To go from here to here, I'm getting smaller, so I'm dividing. What's my magic radical on these? It's 3, because I have 3 different numbers, 30, 60, 90. Well, that's easy too, because 6 root 3 divided by root 3 cancels 6. And quite easily, I go to this by just doubling it. 12. All right? Another practice. I don't have any angles, so I'm at the Pythagorean theorem. A squared plus b squared equals c squared. I have a 9. I don't have my other leg, but I have 41. And square it. So 9, oh, that's what b squared, sorry. Knew something didn't look right. 81 plus b squared equals 41 squared, which is 1681. I subtract 81, that's pretty easy. So b squared equals 1600. And the square root of 1600 is 40. So b equals 40. And I ask myself, does that make sense? Yep, it does. It's okay. As long as it's less than 41. Because the hypotenuse, remember, is the longest side. Alright, 30, 60, 90. Label. Short leg. Long leg. Hypotenuse. This one requires a little bit more work. But remember, I'm dividing, so I'm getting smaller. And my magic radical is radical 3. But I can't have that. So I need to rationalize. You should be good at practicing this by now. So that's 9 root 3 over 3. 3 goes into 9 3 times, so this is 3 radical 3. And then, when I'm going from the short leg to the hypotenuse, I simply times 2. But remember, it's outside times outside, 6 radical 3. Not 6 radical 6, not 3 radical 6. It's outside number times outside number. And that's it.